Today we're going to be solving the week 6 chemistry AMS quiz. It's really easy this week. We just have a few points from last year, but the rest, it's all things we took last week. So which of the following is the electronic configuration? That's for noble gases. We know noble gases are gases that have a full shell. Whenever you see noble gases and you want to find its electronic configuration, look for the 8 in the end. That 8 in the end is going to tell you that it's in group 8, and every single element in group 8 is a noble gas. Other than helium does not have 8 valence electrons, it has 2, but it's also a noble gas. Like He is electronic configuration is only 2. But it's also a noble gas, so that's your only exception, I'd say. Now, moving on. Now here they're telling us that 3.75 of organic compound X were analyzed and they were found to copy 0.8 decimeters cubed. What is the molecular mass of X? Now we need to know two formulas, that PV equals nRT and that N equals M over molar mass. So what we do first is we have our pressure, we have our volume, we have our temperature, but the temperature needs to be in Kelvin. So this is in Celsius, so we have to convert it. And we have our mass. So now we could use our formula. So you do P, which is 2 times 0.8 equals N, which is what we're trying to find. So R is a constant that is equal to 0.08 always, so times 0.08. But always look what they tell you to put it as, because sometimes they tell you 0.082. Times T, 27 in Kelvin is 27 plus 273, which is 300. When you put all of this in your calculator to solve it, you get, let me put it really quickly, you get that your N equals 0.06666, and it keeps repeating over and over. So I'm just gonna round it up to 67, because why not? And then you do mass over moles to get molar mass. So molar mass equals mass over moles. So 3.73 divided by your answer, which is 0.067. So you do 3.73 divided by 0.067. You're gonna get 55.95, which we're gonna almost estimate it to 56, and that is your correct answer. Now let's move on to the next one. Next question, it's asking us empirical formula. So they told us the empirical formula is CH2O, and the molar mass of the compound we're trying to find is 60. This is the molar mass. So to find out what this formula is, or how much is the empirical formula multiplied by, you need to find out how much is the molar mass of this. So C is 12 plus 2, which is H2 because there's 2 H's, plus 16 will give us 30. So 30 to become 60, you multiply it by 2. So this entire formula, you need to multiply it by 2. So C becomes C2, H becomes H4, and O becomes O2. And that is it. And that's how you get your answer for this question. Now let's move on. Okay, for this question, they're telling you a student wants to find the maximum mass of aluminium oxide produced when a sample of 0.8 moles of aluminium reacts with excess O2. So we don't care what information they give us about O2, it's in excess. We always use the limiting, which in this case is Al. So we have for Al, and 0.8 moles this is our reacting RGR. So this is our given ratio. Our given ratio was 0.8. Reacting ratio is 4. And we need to find what's the mass of aluminium oxide. So what grams? We need to find what's the mass of Al2O32. So you do 2 times the molar mass of Al2O3, which is 27 times 2 plus 48, which is 16 times 3. So 27 times, I'm doing it on my calculator for anyone wondering, times 2 plus 48. And 2 times 100, so you get this to be 102, but since it's multiplied by 2, it's 204. So then you do 0.8, and here you have 4, by the way. So 0.8 times 204, you get 163.2. You divide that by 4, you get question mark equals 40.8 grams, and that is your answer. Now let's move on. Here they're asking you for the empirical formula, and for this question I'm gonna add an extra note because a lot of students got it wrong in their last exam. So look, for this question I told you if it's a hydrocarbon or any element with only 2 atoms in it, so here it's H and C only, here's what you do. You do moles of H over moles of C. So moles of H would be, and this is the grams, so this is carbon, so 75 grams of carbon we're gonna take it as, and then what's left from the 75 is 25. 100 minus 75 is 25. So 25 divided the molar mass of hydrogen, which is 1, so you don't really need to do it, over the mass of carbon, which you're gonna take as 75%, over the molar mass of carbon, which is 12. Once you do this all in your calculator, let me do it really quickly just to make sure. 75 over 12, you're gonna get that your answer is 4 over 1, or 4, but yeah. So then hydrogen would be 4, and you'd have you'd have 4 hydrogens and 1 carbon. But let's say in the case where if you had, instead of 4, 3.6, you cannot ever have a decimal point as your subscript. So in that case, you would have to keep multiplying. You would have to multiply the 3.6 by the first time 2. If you get a whole number, which you don't, you get 7.2 when you multiply it by 2. If you get a whole number, then you multiply the C by that same number. Like if you multiplied the 3.6 by 2 and it gave you a whole number, you put C2 H, whatever the whole number was. But let's say you got a decimal again. You take the 3.6 again, the first number, and this time you multiply by 3. If you get a decimal point again, disregard it and take your original number, 3.6, and multiply it by 5. 3.6 times 5, and then you get a whole number. You will either get a whole number when you multiply it with 2, 3, or 5. If you get a whole number when you multiply it with 2, then you multiply the bigger one. So let's say this was for 3.6, this was what you got for hydrogen. If when you multiply 3.6 with 2, you get a whole number, you would multiply the C by 2. But here in this case, you wouldn't. If you multiply it with 3 and it gave you a whole number, you put that whole number for H and that 3 for C. But in this case again, you didn't. When you multiplied it with 5, you got 18, which is a whole number. I'll remove this later. 18 is a whole number, so then you'd have C, 5, H, 18. This is purely an example, by the way. I'm not using real numbers, I'm just telling you that if you get a decimal point, always multiply it by 2, 3, or 5. And I'm not telling you to multiply it if you got a decimal 0.1 or 0.9. If you got something 0.1, round down. If you got something 0.9, round up only. But if you get anything between the two, that's not 0.1 or 0.9, you're gonna have to multiply it by 2, 3, or 5 to get your answer. And that's it for this question. Now, let's move on. For this question, we're gonna have to calculate percentage yield. I think you probably know the equation by now. Percentage yield, I'm gonna write yield as y equals actual over theoretical, but yeah, times 100. To find the theoretical yield, you need to multiply with RRGR. So here you have 0.5 tons, so 0.5 times 10 power 6 being used, and the amount of methanol produced, when it tells you produced, this is your actual. So that's 3 tons. So 3 times 10 power 6 is your actual, and we're going to put that over the theoretical when we find it. So this number, you're going to multiply it by how many tons of CH3OH do you get? First of all, you have to find what's the molar mass of CH3OH. Molar mass of CH3OH would be 12 plus 4, because there's 4 hydrogens, plus O, which is 16. Then you'd get 32. And here you have 2 moles. But you have to multiply the 2 moles by the molar mass. This one's 2 moles of hydrogen 2. Each hydrogen is 1. So then you'd have 4 here. So you're going to do 0.5 times 10 power 6 times 32. Then divide that by 4. You're going to get 4 times 10 power 6. So here you have a question mark, by the way. Question mark equals 4 times 10 power 6, which in tons is, remove the times 10 power 6, 4. But that is your theoretical yield. So we're going to put this times 100 to get your answer. 3 over 4. The times 10 power 6s are going to cancel out. 3 over 4 will give you 0.75 times 100, which is 75%. That's it. Let's move on. Okay. So here they're asking us electronic configuration of boron atom. If they give us B11.5, we know that the 5 is your atomic number. Always look at the bottom number, never the top. The top number is the number of nucleons. So protons and neutrons. But we don't care about this. We disregard it. We only look at the 5. We know that the first shell can only carry 2 and it has reached its maximum after 2. Second shell is going to carry whatever is left. And it has a max of 8. So if you have here 5 left, 5 minus 2 is 3, it works. But let's say you had 10 left, you'd put 2, then an 8, then you'd redistribute the rest on the third ring. Because you can only, on the first one, you can only have maximum 2. At the second one, you could have a maximum of 8. We took this before, but I'm just saying. Now here, they're asking us limiting and excess reagents. 1 mole of hydrogen, 0.25 mole of O2. So here you have 2 moles and 1, and here you have 1 and 0.25. Then this is what you do. You do 1 divided by 2, you get 0.5, and you get 0.25 divided by 1, 0.25. Then you see 0.5 is bigger than 0.25, so the 0.5 is your excess. If it's bigger, and the 0.5 belongs to H2, so that is your answer. You don't put the coefficient with it, by the way. Now here they want us write the electronic configuration of an oxide atom. First, let's write the normal one. So 2 is your first energy level, then 8 minus 2 is 6. 6 is your second energy level. That is for an oxygen atom. They want the ion. So if it's 2 minus, you're going to take that 2 minus and add it to your 6. So it becomes 6 plus 2. So 8. And that's your electronic configuration. And if you want to check if your electronic configurations are right, look at your periodic table. The electronic configuration has to be like any of the noble gases. So when you add them, it has to be one of the noble gases' atomic number. Now let's move on. Again, same thing. Sodium is 11, so 2, then you have 8, that makes 10, and then you have 1. That's for a sodium atom. But for a sodium ion, we know that it is Na+. Since it is plus, you will take the last number and subtract 1 from it. Since it's plus 1, if it's plus 1, you minus 1. So you remove this and this. If it is minus 1, you add 1. But it's plus 1, so it's 2 and 8 again. And 2 and 8 is 10, which matches neon, is atomic number. Now moving on. Here, sodium, they want you to write the actual electronic configuration, which is 2. Then we said 11 minus 2 gives you 8. 11 minus 2 gives you 9. So the second energy level can carry up to 8, and then you're going to have left 1. So 9 minus 8, 1. And the last number is always your group number and the number of valence electrons, and how many numbers you have is your period number, or your row number, they might ask. So group 1 is your last number, and the period number is how many numbers you have. So 2, 8, 1. So 1, 2, 3. That's it. Now let's move on. So the electronic configuration of carbon is 2 and 4. Using electronic configurations, how many valence electrons? Valence electrons is always the last number. Just don't think about it. It's always the last number. For this question, the sample of carbon compound contains 0.96 moles of hydrogen, 0.24 moles of carbon, and 0.48 moles of oxygen. What is the simplest formula of this compound? So first of all, what you have to do is you have to look at the three numbers of moles and find the one with the least. What's the smallest number? In this case, it's 0.24. So then you do 0.96 over 0.24. Then you do 0.24 over 0.24. Then you do 0.48 over 0.24. All of them over the smallest number of moles. Here you're gonna get the answer to be 4. Here you're gonna get the answer to be 1. Here you're gonna get the answer to be 2. Then you're gonna go back. The 4 and the 0.96 belongs to hydrogen. The 1 belongs to carbon, and the 2 belongs to oxygen. They want you to write it as in CHO order. So the carbon has 1, so you don't write the 1. H has 4, so you write the 4 here. O has 2, you write the 2 here. And that's how you get your answer. Now, let's move on. Okay, for this question, oxygen has atomic number of 8. So 8, like we said, first level only can carry 2, then 8 minus 2, you'll be left with 6. This one is like this. Okay, this question. Misclicked, by the way. Mistyped it. So if we take 60 ml of a solution out of a 0.4 molar potassium hydroxide solution and add it to 140 milliliter of distilled water, what will the concentration be? I don't know if you remember, but we took this last year. You have to use C1V1 equals C2V2. So what do you do now? You take volume 1 and concentration 1. So 60 times 0.4 equals concentration 2, which is what we need to find, times volume 2. How do you find volume 2? You take the 60 and you added it to 140 ml. What does that mean? You took 60 plus 140. 60 plus 140 will give you 200. So C2 times 200. Solve it on your calculator. 0.4 times 60 will give you 24. And then 24 divided by 200 will give you 0.12. So C2 equals 0.12. That's your answer. Now, for this question, a sample of 20 grams of CaCO3 decomposes to produce CaO and CO2 according to the following chemical equation. How many grams of CaO are produced? So you have 20 grams of this, and the original one, CaCO3. So Ca is 40 plus C is 12, O3 is 48. So you have originally here 100 grams and here 20 grams. And you need to find how much grams of CaO are produced. So how many grams here are produced? How many grams are produced? CaO has a molar mass of 40 plus oxygen, which is 16, so that's 56 grams. Then you do our cross multiplication. 20 times 56, you get 1120 divided by 100, which is 11.2. And that's the answer. Now, what volume of CO2 was produced? So we remove this, we don't need this anymore. You need the volume of CO2. So volume at STP, which means 22.4. Memorize it. STP 22.4, RTP 24. Again, cross multiply, but this time with 22.4. So 20 times 22.4, you're gonna get 448 divided by 100. you're gonna get 4.48. And that's how you do it. This is all last year's material. Now, moving on, question 17. What mass of Fe2O3 must react to produce 90.5 kilojoules? So what we're gonna do is, here we can see that we have negative 118.1 kilojoules. There's no such thing as negative energy. The negative is telling us that it's in the product side. So just put plus 18.1 here. So what mass of Fe2O3, what mass, this is usually 160, they gave it to us, do you need to produce 90.5? So this is what's given, this is what's in the equation, and now just cross multiply again. So 90.5 times 160, you're gonna get a long number, divide that by 18.1, you're gonna get this question mark equals 800. Now, what volume of CO2 is produced at RTP when 90.5 kilojoules are released? So now we need what? How much is the volume of CO2 at RTP? So what decimeter cubed? So 3 times RTP, which is 24, is what we're gonna use. So 90.5 times 3 times 24 is gonna give us 4,344. Divide that by 18.1. You're gonna get a wrong answer. Wait, what? Let me see something. I probably mistyped something in my calculator. So 90.5 times 3 times 24. Oh, yeah, I mistyped the numbers in my calculator. Divide that by 18.1. You're gonna get 360 as your answer. Which, these are both your answers. So all of this is just RRGR with what's given and what's needed. Now, moving on to the next question. So next question is asking us how many moles of KCl are required to produce, again, RRGR. So, how many moles of KCl? So moles, here you have 2 originally, to produce 14.2 grams of this. Cl2 is 35.5 times 2. So it will be 71. Keep it in mind. Always they ask us about Cl. So then you do 14.2 times 2. Then divided by 71. You will get 0.4. 3 significant figures, add 2 zeros after the 4. Now, how many grams of Cl2? So now you want to switch it around. How many grams of Cl2? Here you had 71. Are going to be produced from 0.3 moles of hada. Here you had 1 mole and now you have 0.3. So 0.3 times 71. Then divide by 1. Doesn't matter, you're going to get 21.3. And that's it. Now, let's move on to our last question. They're asking us a limiting reagent and excess reagent. So we have a sample of 5.5 grams of P4O6 reacting with 20 grams of O2. So so you have 5.5 grams reacting with P4O6, which is 220 grams. And then you have 20 grams reacting with O2, which you have 2 times 32, which is 2 times 32, 64. So you're gonna see that you're gonna do 5.5 divide by 220. You're gonna get here 5.5 divide this. So you're gonna get 0.025 here. And here you're gonna get, 20 divided by 65. You're gonna get, I wrote 65 instead of 64, my bad. 0.3125. We can obviously tell that this one is bigger, making this the excess reagent and this the limiting reagent. So that is the limiting reagent, P4O6. Oh my gosh, I'm really sorry. So now, what mass of P4O10 is produced? So okay, I'm actually gonna P4O10. What do you do for this is you take the molar mass of this, you multiply it by the coefficient, if there is, here there isn't. Then you're gonna take the the limiting reagent ratio and multiply it with this. You could do RRGR with the limiting reagent. I prefer to take your ratio, which is the number you get, multiplied by 284. So 0.025 times 284 gives us 7.1 with 3 significant figures, 7.10. That's it for the chemistry quiz. Hope you understood everything. Have a good day. Bye.